Today, we are going to identify if the sequence is bounded above, bounded below, or both bounded below and above. If there exists a number m such that the sequence an is less than or equal to m for every n, we say the sequence is bounded above. The number m is sometimes called an upper bound for the sequence. In this example, the given sequence is monotonically increasing. And as you can see, with the given graph, our sequence will either be equal to m or will not touch or no sequence term will be equal to m, or no sequence term will go beyond the value of m. Hence, m is the upper bound of the given sequence. In this definition, if there exists a number n such that an is greater than or equal to n for every n, we say the sequence is bounded below. The number n is sometimes called a lower bound for the sequence. In this given example, the graph of the given sequence is monotonically decreasing. Now, with the given graph, it's either one of the sequence term will be equal to n, or will be less than, or none of the sequence term will be equal to n, so meaning it will not touch on this line. Okay, the graph of this given sequence term will not touch on this line and will not go beyond to this line, meaning no sequence term will be less than the value of n. If that will be the case, then n is the lower bound of this given sequence. Now, if the sequence is both bounded below and bounded above, meaning it has both upper bound, which is m, and lower bound, which is n, then we call the sequence bounded. In this given example, we will identify if the sequence is bounded, bounded below, or bounded above. For the first example, we have the sequence 1 over n. If we are going to write the first 4 sequence terms, we have 1. If n is 1, our a sub 1 is 1. If n is 2, a sub 2 is 1/2. If n is 3, a sub 3 is 1/3. If n is 4, a sub 4 is 1/4. Now, the graph will look like this. In the previous video, we were able to prove that the given sequence 1 over n is monotonically decreasing, with 1 as the highest value of sequence term in the sequence 1 over n. With the graph, it shows that the sequence is bounded above by 1. Well, to find out, this is bounded up, the graph is bounded above. Okay, so it means that the given sequence will not, the graph of the given sequence will not go beyond this line. Okay. Now, since we already know that the given sequence is bounded above by 1, let us try to find out if the sequence has a lower bound. Now, to determine if the given sequence 1 over n has a lower bound, let us find the limit of this sequence. So the limit of the sequence 1 over n as n approaches to positive infinity. Okay, so let us have n equals to 1. The value of 1 over n is 1. If n is 10, so the value of 1 over 10 is 0.1. Now, if the n is 50, 1 over 50 is 0.02. If n is 100, so that's 1 over 100, and it's 0.01. If n is 1000, so that's 1 over 1000, and it's equivalent to 0.001. So what does it mean? It means that, or it implies that, as n approaches to positive infinity, the value of 1 over n is approaching to 0. Therefore, we can say that the sequence 1 over n has a lower bound which is 0. And so we can say also, or as a conclusion, the sequence 1 over n is bounded because it has a upper bound of 1 and it has a lower bound of 0. If we are going to graph it, then it will be like this. So we have 1, and of course this is 0. Okay. So the sequence 1 over n is monotonically decreasing. So the graph will look like this. Okay. 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 For the second given sequence term, 2n squared minus 1 over n, the sequence can be written as, if n is 1, a sub 1 is 1. If n is 2, a sub 2 is 7 over 2. If n is 3, a sub 3 is 17 over 3. If n is 4, a sub 4 is 31 over 4. These are the first 4 sequence terms of the given sequence. Now, to determine whether the given sequence is monotonically increasing or decreasing, we can also determine its monotonicity by getting the derivative of the sequence. Okay? Now, since the sequence is a function, is considered to be a function, because for every value of n, there is a unique value for a sub n. Okay? And so, let f of x be equal to 2x squared minus 1 over x. Then the derivative of it is 2x squared minus 1 over x squared. Now, if we are going to substitute greater than 0 value for x, then the derivative is positive. Again, for all values of x greater than 0, meaning if we're going to substitute here in x all integers greater than 0, then the derivative is positive. If that is the case, then the sequence is monotonically increasing. Now, let us determine if the given sequence 2n squared minus 1 over n has a lower or upper bound, or it has both. Okay, so we will graph, but before that, let me convert the fractions into decimals. Okay, so this is equivalent, 7 over 2 is equivalent to 3.5. 17 over 3 is equivalent to 5.6. 31 over 4 is in decimal, it's 7.75. Okay. Now, and also from as what we have determined, that the given sequence is monotonically increasing. Okay, monotonically increasing. Therefore, with this with this given first four sequence term and the fact that the sequence is monotonically increasing, therefore we can say, okay, if we're going to graph it, it's clearly that 1 is the lower bound. Okay, so if we're going to graph it, it will somehow look like this. Okay, so the lower bound is 1. Now let us try to identify if the sequence has an upper bound. Okay, to determine if the sequence has an upper bound, so let us find the limits of the given sequence. Okay, so to get the limit of 2n squared minus 1 over n as n approaches to positive infinity. Okay, and then we will apply some of the theorems that we have discussed last time. So we have this one, 2n squared over n squared minus 1 over n squared all over n squared. Then we can cancel it. Okay, then this one as well, it will be 1 over n. And this one, it's 2. And then based from the theorem, 1 over n squared is 0. And so we have 2 over 0. Now based from a given theorem as well, okay, the limit of 2 over 0 as n approaches to positive infinity is equal to positive infinity. Okay? Hence, we can say that the given sequence has no upper bound. Okay? The sequence has no upper bound. Okay? And so we were able to determine that the given sequence 2n squared minus 1 over n is bounded below because it has only a lower bound. Thank you for watching. Please subscribe to my YouTube channel. Thank you.